Okay, so today I'm going to walk through our XFLR project 3. You start off by going to direct fold design. You have to load in our Clark Y airfoil. You go to open, saved. It's right here, as you can see, and then you go over to file, and then you can do direct analysis. I actually like to change my name to CLARKY. Once you do that, you can come over to File, Direct Analysis. Here, you can define analysis. Type 1. Our Reynolds number, we're going to go to 1 million. Once you have that, we're going from angle of attack of -5 to 20 in iterations of 1. You can analyze that. Here you can see the analysis. We have your CL alpha, CLD alpha, and CL over here. These are the main three that we need. You can export these graphs from current graphs, export graph, and as you can see here, I've exported all these graphs already. After you've done that for all three of these graphs, which I'll show you real quick in here, for your airfoil, here is your alpha, CLD, and CD. For CL, your drag coefficient and your lift coefficient charts that was imported from our XFLR software. And then from there, to start working on wings, you have to do analysis and do a batch analysis. I went from 100,000 to a million in increments of 20. Your alpha values stay the same, max ratio is 100. Analyze goes by pretty quick. But you can see all the different increments, and for all the different Reynolds number, how each of these charts behave. And this will be helpful when you go over to wings and start working on that. So once that's done, you can close. You can go to File, Wing, and Plane Design. Over here, you go over to Plane, define a new plane. I like to name it what I'm using, so just copy paste this over for what I use for all of them. It's a wing with an aspect ratio of 4. You can take off our fin elevator. You can define it here. I usually put everything to 0 for offset, no twist. Or did I do 0.5, 0.5, and I did 2. No, actually I kept it at 1 just to give me the aspect ratio for 4 right here. And then of course our airfoil, you want it to be the Clark Y. You can save that. You save that here. You can see here. Once you do that, you can define analysis, type 1, our free stream speed. I'm going to keep it at 10. Analysis is LLT. Save that. You can do a sequence from -5 to 20. That's what the assignment asked for, and increments of 1. So you analyze that. And it goes through pretty quick. And you can actually come here and see your LCD, CL over alpha, CLD, and alpha graphs right here. You can also see your induced angle and your induced drag coefficient graphs here. And that this is for a wing with the with the aspect ratio of 4. And you can actually see some values here too. You can see the velocity, your coefficient of lift, and such other things with this. Let's see if you go to like 7, our coefficient of lift. This is the coefficient of lift we use later on for our calculations. And for the rest of the other 3 wings, we need to go define a new plane. We take off the fin and the elevator. Again, to name it, copy paste what I used. you define it here, and offset I'm put to 0. I put to 0.75 just to get some different widths, chord lengths for there, and see how that really affects it. And I think I have to put this to 3 to get my aspect ratio of 8. Again, your X foil. Make sure you bring that to Clark Y. Save it. Save it here. Again, analysis, define analysis. Save. You do your angle of attack from -5 to 20. Gets that done pretty quick. Now you can come here and see both these wings with aspect ratio of 4 and aspect ratio of 8 and how that affects it. And same thing for your induced drag and your induced angle. So then finally we come to our last wing. Define it here, offset to 0. The 0.9 here. I had an issue when I put when I actually did 1, but then I put 5.3, I believe, 5.4 to get my aspect ratio. There you go, 5.4 to get my aspect ratio of 12 here. Your taper ratio is 1 as it needs to be. Save that. Oh, I forgot to put airfoil of the Clark Y on there. Save. Define analysis. Keep everything the same. Again, angle of attack from -5 to 20. Analyze. There you go. Now you can see here. Once you have it here, these 3 graphs are the 3 graphs that you need. You can export graph, and you can just name it what you need to name it. And as you can see, I've done that for each of the wings. Your CL versus alpha graph, your CL versus CD graph, your CL over CD versus alpha graph. It's all here. Oh, let's say that again, and then of course you to get your induced angle and your induced drag coefficient. Again, the same way you can export these graphs, and you can put it here, as you can see, for airfoil of 4 I did the induced drag and induced angle for each of those 3 different types of wings. That is all there. So now I can start showing you guys that. So this is the airfoil. This is my alpha versus CL, alpha versus CL over D, CL and CD graphs that you have here. This is what you have for the wings for each of the different areas. I've done those, separated them out. I kind of put them all together so it's easier to see and easier to view. Once I have that, I put them all together to get a CL versus alpha chart here. Once I had the chart, I had to get the lift curve line to get the slope. Actually cut a few of these values out. I stopped at 9 at the angle of 9, angle of attack of 9, just to get a straighter line and get a better lift curve slope, as you can see here. And to see the max lift coefficient, just took the max from here, and this is the corresponding angle of attack. Same thing for your CL over CD, the angle of attack. Same thing, took the max, cut the corresponding. Here you need to get your 0 lift drag coefficient, and you just have to see where it gets to 0. I had to interpolate to get the CD or the 0 lift drag coefficient. I interpolated to get these values. And then this is the induced drag coefficient for the 3 different wings. As you can see here, the difference in them, it's kind of cool. And it's kind of nice to view it. Same thing with the induced angle of attack, how different it is for different, just different sizes of just different chord lengths and different the wingspans. And then finally, of course, we had to do our calculations. These are the values I got from the X-foil, and then from there I did some calculations, as you can see here, for induced drag, calculated using the CL that I got from X-foil, induced angle, and then the downward velocity as here as well. And then I put that all neatly into a table, starting with each of the graphs, titled it. That's the 3 graphs. These are the other 2 graphs for the induced drag coefficient and the induced angle of attack. And here are your tables. And then the YouTube link will be provided here. Thank you guys.